Hello everyone, this is Ayushi Gupta. Welcome to the 23rd episode of Microsoft Hour of Code, brought to you by Millionlights. Millionlights is a TV channel dedicated to improving the skills of people in their employability. Now let me tell you more about the Microsoft Hour of Code. Microsoft Hour of Code is a series of lectures, courses and talks by experts who are going to be discussing the latest Microsoft technology topics related to programming and industry forecasts that are all focused on employability. Today, we are going to learn the C# fundamentals. This is a beginner's course for people pursuing computer science. These episodes have everything you need to upgrade your skills. These courses are not only beneficial for students, but also for working people. As you know, today we are going to learn C# fundamentals. This content has been created by our partner Microsoft. We have Bob Tabor from Microsoft with us, who will help you learn the fundamentals of C#. But before we start, you need to have a computer system with a 64-bit processor or a 32-bit processor. Other requirement tools are Windows Notepad and any web browser such as Internet Explorer. If you want to learn a different programming language, C# is a great place to start. Tune in to learn the basics of C# language and learn to apply them in your programming endeavors like video games, mobile environments, and client apps. Now let's move towards the course. The topics that we are going to cover in this episode are understanding scope and accessibility modifiers, in which we will explore variable scope and how accessibility modifiers are used by .NET Framework class library. These are used to expose or hide implementation of their given services to consumers of that given class. Understanding namespaces and working with the .NET class library, in which we will learn about namespaces and how to find the classes for your applications by searching Bing and MSDN. Creating and adding references to assemblies, in which we will learn about .NET assemblies, code libraries, and executable debug and release version of assemblies. We'll see how to reference assemblies, utilize NuGet, and create references to custom libraries. So let's get started.
Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, we haven't spent a lot of time talking about variable scope. It's actually extremely important. We recently learned that it also impacts the lifetime of objects, so we want to spend a little bit more time really making sure we understand the scope of the variables, whether they be variables holding simple types or references to complex types in our applications. And not only do I want to fully explain that, but then I want to use that as a launching pad to explain keywords like public and private that we've seen several times in our course up to this point, but I haven't really talked about. Before we talk about that, let's talk about variable scope. So let me start by saying that whenever you declare a variable inside of a block of code, that variable is only alive for the life of that code block and any of its code blocks, any of the interior code blocks or code blocks inside of that code block. Meaning that when the code block is finished executing, the variable that was defined inside of that code block is no longer accessible and its values are disposed of by the .NET Framework runtime. So we'll start by looking at how that is impacted by common code blocks that we've been working with up to this point, and then we'll use that and expand beyond there. So you can see that I've created a project called Understanding Scope, and you can pause the video and catch up with me. I want to create this project and focus on testing how variable scope works, and so I'll start with a pretty simple code example. Again, the concepts that we talk about also apply to object references, not just variables that hold simple strings and integers. All right, so let's start by creating a simple for iteration statement, and we'll just loop through 10 times, and we'll do a console.writeLine containing the value of I. And then here we'll do console.readLine so we can see our results, and we'll run the application. And as we would expect, we can see values from 0 through 9. Now, what if I wanted to access the value of I here right after the closing curly brace for the for statement? We'll notice that I'll get a red squiggly line under I, and if I hover my mouse cursor over it, it says that I does not exist in the current context. Why? Because I is now outside of the scope of its definition. We defined I inside of the for loop. It's available inside the for statement itself plus in the code block below it, but not outside of either of those. All right, so we'll have to comment that out. So second, let's start, we'll continue by going and creating a string of j equals empty string. And what we'll do inside of our loop here is just go j equals I dot toString. Now let's go outside of our loop. Will we be able to access the value of j? So let's go outside of the for, and will we be able to actually print to screen the value of j? All right, we are not getting any errors, so let's run the application. And you can see that the last value that was inserted into j was the value 9. Since we defined j outside of the scope of this code block, of the for statement and its code block, we can access it inside of that code block and outside of that code block as well. All right. Next up, let's look at the at something like this, where we'll actually create what's called a field or a private field. So we'll go private static string k equals, and a private field is sort of like a property, except it's private in nature, but it is available to all of the members of the class. So we should be able to see k inside of our for loop. So let's do I.toString. We should be able to see it here as well in the outside of the for loop, like so. Let's go ahead and run the application, and you can see that second console.write line will also display the number 9. But the real question is, what if we were to create a helper method, static void, and we'll just call this helper method. And here we'll go console.writeLine, and we'll say this is the value of k from the helper method, and we'll do that. Now here we'll call the helper method like so. Will this work? Will we be able to access the value of k as it was set inside of our for loop outside of our static void main? Let's run the application, and you can see that we can in fact get the value of k from the helper method. Why? Because k was defined at, I guess you could say, the class level. It is a sibling to static void main and static void helper method. Therefore, it's accessible to each of these as well as any of their inner code blocks. All right, hopefully this is starting to make sense. Let's go inside of the for loop now, and here what we'll do is a simple if statement. So if I is equal to 9, so on the very last run of this, then let's declare a string called L, and we'll set that to string, the I to string, and then outside of that we'll go console.writeLine the value of L, and as you might anticipate, we will see that L does not exist in the current context. Why? Because we declared the value of the string variable L inside of the if statement's curly braces, outside of those curly braces, it's no longer accessible, so we have to comment that out. All right. So hopefully this solidified in your mind many of the combinations that we can use in determining whether something's in scope or out of scope. And if you had any confusion about this, hopefully that cleared it up a little bit. All right, so now let's move on to the larger topic of accessibility modifiers. We've been creating classes, specifically the car class up to this point, and whenever we were creating methods, I would typically use the public keyword. Occasionally I would use the keyword private like I did here in line number 11. Private and public are both accessibility modifiers. They're used to implement a tentative object-oriented programming called encapsulation, which is actually pretty important. So in a nutshell, you should think of classes as black boxes. And whenever you think of a black box, maybe you can think of like one of those old style television sets. Maybe your parents or grandparents had one. I remember as a kid us having one. There were no remote controls. You had to get up, walk across the room, and actually turn the dials of the TV in order to tune to either VHF or UHF channels. You had another volume maybe or a dial where you would adjust the volume. You had an antenna in the back, so you would connect this wire out to your antenna, and you had another one where you would plug it into the wall. And everything else about the television was self-contained. Now, as a kid, I was fascinated whenever my dad would pop off the back of the television set, and he'd go and try to fix it by changing out the tubes. And it's always seemed like magic to me because I knew absolutely nothing about the innards of televisions. All I knew were the public interfaces, the button for on-off, the dials to turn the channel, the dial to turn the volume up and down, the antenna, whatever that did, and the little plug that would obviously give it electricity. But frankly, in order to use the television set, that's all you really needed to know, right? You did not have to know anything about how a television worked. All you really needed to know was how to plug it in and change channels, turn it on and off, and then adjust its volume. And that is exactly how your classes should be treated. All the important behind-the-scenes functionality should be encapsulated behind interfaces like public methods and public properties. Now, classes might, in fact, have private fields like we looked at here in line number 11, or they might have private methods that are used behind the scenes to enable all the magic that goes on inside of that class. But the consumer of the class shouldn't know anything about the inner workings of the class in order to work with the class, to operate the class. All they need to know is what's publicly exposed through the public properties and public methods. So in a nutshell, private means that a method can be called by any other method inside of the same class. So I used the term private helper method a number of times accidentally. Essentially, when I use the term private helper method, I'm talking about a private method that adds some additional functionality to those public methods that are exposed to anybody who needs to work with the class through that method. A public method is what's actually going to be then called by somebody outside of the class, some other code outside of the given class. And private methods are only going to be called by members inside of the class. Okay, so let me do this. I'm going to paste in some code to recreate our car class. And here I have a public and a private method. The public method is called do something, and the private method is called just helper method. All right, and these are not very interesting examples. I want to keep this as simple as possible. Now, from the outside of this car class, let's just kind of roll this whole thing up here and save it. And now whenever I want to go here inside of my static void main, I might want to work with the car class. So I'll go car, my car equals new car. And then I'll do my car dot, and notice that I can only see the public method do something. Now, I might happen to know there are other methods also inside this class, but I can't see them from outside. Their visibility is hidden to me because they're marked as private. All I really need to know is how to use the do something method, and if I understand that I can call that, all the implementation details will be hidden from me, but it'll work as I expect it to work. Here you can see that it merely prints out the words hello world. All right. Now, how it does that, whose responsibility inside of the class it is to actually display that, that's none of my concern. All I need to know is how to call the public method do something. Okay. So in a sense, the consumer of the car class has absolutely no idea that that helper method even exists. All it really knows is that there's one public method, and it could call that public method, but it doesn't know any of the hairy implementation details, right? Now, I use the term in a sense, that in a sense, the consumer of the car, the consumer is going to be a software developer, and a software developer is going to be able to drill in and say, oh, I see how it's doing its work. It's actually making a call out to this other private helper method. And so, you know, there is a sense in which it is public to developers, but it's private from the perspective of the consumer, which is this main method. It can only see the do something method, not the private helper method. Okay, that's all we really mean here. Now, admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation, that we typically want to hide the implementation of our classes behind well-known public interfaces, in this case, a friendly method called do something. And the purpose of this lesson is to better understand the notion of scope, because we said that once variables, especially variables that contain object references, fall out of scope, their objects will be garbage collected. Furthermore, it's important to understand that there are parts of classes that you have access to and parts of classes that you don't have access to. Now, if you ever decide that you want to create your own custom classes someday, even a library of classes that represent the business domain of your company or of your specific application, it could be a game, you should strive to expose public methods and give a simple, straightforward, obvious way to call the public methods from your class, but keep all the other helper method, all the other internals privately tucked away and not available to prying eyes. So you don't want a developer to simply go fiddling around inside of all of your methods and use your class in a way in which it was unintended. You want to give them a way to use your class properly through the methods that you've designed and that you've made available through public interfaces. And this also will help to remove any ambiguity in the usage of your classes. And it should be much cleaner as well. All of these things were under consideration whenever the developers built the .NET Framework class library. In the .NET Framework class library, methods and properties are exposed using the public keyword. Now, they might also be using private fields and private methods behind the scenes, but you would never know. They may use other types of accessibility modifiers as well. There's actually a couple available called protected and internal. However, these are primarily for whenever you're working either in a rich inheritance relationship between classes and you're building a rich inheritance hierarchy between classes, or whenever you're working with a very large library that's compiled into separate assemblies. That's when some of these other accessibility modifiers might come into play. They're topics that are beyond the scope of this absolute beginner series, but topics that I do cover on Developer University. So if you want to know more about object-oriented programming, encapsulation, by all means, go ahead and... All right, we are well past halfway through this course. You're doing great. We've already covered the most difficult material already. Now we're just adding on details. So you should be encouraged by that you're still plugging away at this. And you're doing great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously in this course, I said that the .NET Framework class library is merely a collection of classes, each containing methods filled with functionality that we can utilize in our applications, but we didn't have to write. Microsoft has spent tens of thousands of man-hours building and maintaining this library of code, and we can benefit from it by merely calling into its classes and methods inside of our applications. Now, the framework class library is massive. Thousands of classes, each with their own set of methods. And so the developers of the framework class library wisely decided to split this library of code up into multiple files. Just imagine if you had to load the entire library into memory every time you wanted to run your application. First of all, it would be excruciatingly slow, and then secondly, it would probably take up the majority of your computer's memory. And so they split up the code into multiple files. These code files are called .NET assemblies. In fact, even the applications that we build, they're ultimately compiling into .NET assemblies. As you can see, I have a new project called Assemblies and Namespaces already open. I've added 2 lines of code. If you want to pause the video and catch up, that would be great. In lines 13 and 14, I'm merely printing hello world to the screen and then pausing the execution of the application. However, even in this application, a executable .NET assembly is being generated the very first time that we run the application while we're debugging. So now, if you want to take a look at what happens, go to your projects directory, and inside of the project folder, you'll see that there's a bin directory. We avoided this very early in this course, but now I want to talk about it briefly. The bin directory will contain both a debug and a release version, ultimately a release version. The debug version will contain additional files required by Visual Studio to connect to the execution of the compiled executable. This allows us to step through the execution and pause the execution line by line in the Visual Studio debugger. Now we can additionally then, after we've created our application and thoroughly debugged it, we can say I want to create a release version of the application, and go to Build Solution in the Build menu, and it will create a version of our application without any of those debugging symbols, without that connection to the debugger. If you look at the file system, you might be a little confused to see that it also has a lot of those extra files in there, but they're basically ignored. But that is what's going on behind the scenes. Notice that in each of these cases, we're building an executable file that will run, and we could even just double click it and run the application from here like we did before, right? Now that is different from the type of .NET assembly that allows you to create a library of code that can be shared across multiple projects. In that case, you'd be compiling a project into a .dll file extension. And we can create a code library. I'll show you how to do that in another video. But at any rate, the .NET framework has to already be installed on any computer where you want your application to work or to run. Fortunately, basically every copy of Windows already has the .NET framework runtime and the class libraries installed in a location that's globally accessible called the Global Assembly Cache. And so every .NET application can reference the same set of assemblies in that one spot on your hard drive. Now you might say that whenever you build your application and set up your application, you may not realize that by choosing to create a file new project and then selecting the console window project template, you were actually creating references to those files in the .NET Framework class library. That's one of the functions of the setup routine for a project template. So if you take a look at the references node underneath your project in the Solution Explorer over here on the right hand side, you'll see that there are some references already to these these things like system, system.core, system.data, system.net, and so on. All right. Now, we'll talk about what these are in just a moment, but that's indicative of the fact that we have references into files of the .NET Framework class library that the creator of the console window application thought we might be or might find useful at some point. All right, so we'll come back to that in just a moment. Now, sometimes you'll need an assembly from the .NET Framework class library that has not been referenced, and I'll demonstrate how to do that in an upcoming lesson. Or perhaps you need to add a reference to an assembly created by a third party, maybe even yourself. I'll demonstrate not only how to create your own class library, but then also how to create references to third-party assemblies as well. Again, there are tens of thousands of classes defined in the full .NET Framework class library. In a few cases, the same class name was used, or at least there was the potential for it to be used. And so when that happened, the creators needed a way to be able to tell one class from a different class. And so they introduced the notion of namespaces. And namespaces are like last names for your classes. So think about your name or my name, for example. Somebody might say Bob loves coffee. And you might say, well, which Bob? There's like a billion Bobs in the world, right? But if somebody were to say Robert Theron Tabor likes coffee, well, that narrows it down. I'm pretty sure that I'm the only person in the world that has that combination of first, middle, and last name, all right? So I could either use the full name, Robert Theron Tabor, to reference one person, or once we understand the context of who we're talking about, maybe we're talking about only people in this room, then you might say, well, Bob likes coffee, he's the only Bob in this room, so they must be talking about Bob, right? So the same idea works with your code. We could use the full name of the classes that we need inside of our application. So for example, the full name of the console class is actually system.console.writeLine, all right, or the system.console class, right? That's the full name of the class, and then we're calling the method in that class. However, you'll notice that I didn't have to use the word system here. Why not? Well, because we used a using statement at the very outset of this code file, which says, I want you to look inside of these namespaces whenever you find a class reference that you don't recognize. And so the C# compiler, it finds the word console and it says, I wonder where that came from. And it begins to look through the namespaces listed in the code file, and it says, oh yeah, I found a class name called console inside of a namespace called system. All right, and so it thinks, all right, well, that must be the console class that he's talking about. Now, occasionally you might have two classes with the same name and you've added using statements for each of these inside of your code file. When that happens, you merely need to disambiguate by adding the full name of the class instead of relying simply on the using statement. Now you'll notice here that by default the program.cs file has a number of different using statements. In my text editor, they're kind of faded out a little bit, which indicates to me that they're not being utilized at this moment. So we could remove unused using statements from our code and our code will compile just fine. Again, this is a convenience for us that was set up for us by whoever created the project template for a console window application. So to further illustrate this idea, let's talk about how we can go about using the .NET Framework class library to do meaningful things and how we would go about finding the source code or the classes we need to do something cool in our application. So for example, maybe I want to write data to a text file. How could I go about doing that? Well, I might open up bing.com and I might search for, and I'm going to type in site Microsoft.com, so I'm going to limit the search results to just those that are returned by Microsoft.com. All right. This is going to help me find the documentation specifically created by Microsoft as opposed to third-party articles or whatever the case might be. So site:/Microsoft.com, and then I might just say write to a text file and then using C#, right? And so one of the top results are from msdn.microsoft.com, and MSDN stands for the Microsoft Developer Network. This is your primary source of information as a software developer on the Microsoft platform. And so in this case, here's a how-to article that will describe the code that we would need to write in order to write data to a file. Here's a long code example. In fact, it gives us 3 examples in one. And we could use one of these examples in our application in order to write data to a file. And we might decide to go ahead and use this second example. It comes close to what we want to work with here. And I copy it and paste it into my application. And I might remove some of the extra information here just because I don't need it. And I may need to modify this path. I believe I created a folder called Lesson 17 for this purpose. And notice that it's going to use a class name file and a method called writeAllText. Now in this particular case, notice that we already are given the full namespace of this file class, system.io.file. Now what we could do is actually remove that from here and go up and add a using statement for system.io, like so. All right, and notice that the compiler will find it and we'll be able to run our application. And got a little message there because I was in release mode. Let's go back to debug and start that over again. All right, and we don't get any feedback there, but if we were to open up our Lesson 17 folder, we would be able to find the text in a text file. Great. Okay, so now we can use that little snippet of code to do what we want to do. But notice it all started by searching on MSDN, finding a code snippet that we could use, and then we can modify it and add our own text here that we want to write this to our file, right? Okay, so that we start stitching things together. So that's one thing that one way that we can find the features inside of the .NET Framework class library that we need is to search on MSDN. Let's try one more quick example, and let's go back here, back to bing.com, and here again I want to go site:/Microsoft.com, and then I want to do C# download HTML as a string, and I might find another reference. Now this is a different style of web page. There is one web page on MSDN for every class and every method in the .NET Framework class library. So in this case we're looking at a specific page for this download string method. And if you were to look at the remarks and some of the the syntax and some of the exceptions that it would throw, what we ultimately get to is a little snippet of code that we can copy and that we can paste inside of our application. Now notice what happens this time. It does not recognize the term web client. Why not? Well, we may not have the assembly referenced in our project, or we may have the assembly referenced, but we do not have a using statement that would include the web client class. So to remedy this, I'm going to hit Control period on my keyboard, and it says that it found this class in system.net. So we can automatically add a using statement for the system.net class by merely hitting the Enter key on my keyboard, or I can just go ahead and say, let's go ahead and use the full name of the class here. I'll choose the first option using the arrow keys and then the Enter key on my keyboard. Notice what happens. It adds a using statement for system.net, and then notice that the web client class is now found. It is obviously in a different color. There's no red squiggly lines, so it looks like it found the correct class that we're looking for. Now we merely need to give it a URL, so let's try msdn.microsoft.com, like so, and then we will just write this out to screen reply. And then we might even rework our application and attempt to save that into our text file as well. All right, so let's see what we get here. Hopefully this will work. We'll run the application. All right, it took a moment, but it loaded up a bunch of HTML into our console window. We can see the closing body and the closing HTML tag. Now if we were to go back to our folder and find our lesson 17 folder and open up our text file, we see here is the full web page that we scraped off of msdn.microsoft.com. Okay, so that pretty much wraps up what I wanted to say in this lesson. We are able to utilize the classes and methods in the .NET Framework class library, and we can find what we need by doing simple searches in bing.com using site:/microsoft.com to find the classes and the methods that we want to work with. Once we find those classes that we want to work with, and we find maybe even little code snippets, we can copy those into our program, and we may need to at that point fix the references to those classes. Now in this first case, remember that it gave us the full name of our file class, system.io.file, but in the second case we had to provide the using statement system.net in order for the compiler to find the class that we were wanting to reference and work with. And ultimately we did that with hitting Control period on the keyboard to add a using statement to the very top of our code. We talked about the purpose of namespaces to provide disambiguity between class names. We talked about the using statement as a way of creating a shortcut or a context and say we're not talking about every class in the .NET Framework class library. We're only talking about the classes that happen to be in these namespaces. So if you find, Mr. C# compiler, if you find a class that you don't recognize, look in those namespaces first before you complain. Okay, so we're going to continue on these ideas in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now, previously I said that the creator of the console window application project template added references to those assemblies in the .NET Framework class library that we as developers might find useful for the majority of use cases. However, if we need an assembly containing some portion of the .NET Framework class library that has not already been added to our project, then we can simply add a reference to it. So this is one of three ways that we'll demonstrate on how to add a reference to an assembly. The first being an assembly from the .NET Framework class library. Now there's a number of different ways to go about this. The easiest way, I think, is to go to the Solution Explorer and then right-click on References and select Add Reference. And here you can see there are a series of, I guess, tabs along the left-hand side that would allow us to choose from the various types of assemblies that are available to us. We want to choose the framework, and these are all of the assemblies that are part of the .NET Framework class library. All right, now and you can see that there's already check marks next to a number of the system.this, system.that, system.net.http, and these contain a number of different classes, each with many methods, and these are just automatically accessible. If we needed something that is not contained here, then we could choose, for example, to just select a check mark next to the one that we want to add to our project, system.net, and click OK. And you can see that it's added a reference to system.net into our project in the Solution Explorer. Now we can reference any of the classes and utilize any of the methods in that particular assembly. Okay, so that's one way if we need to access some part of the .NET Framework class library. Now, in addition to that, there are libraries that are created both by Microsoft and there are libraries that are created by by open source contributors, other companies that are provided for free for very specific purposes in our applications. And so these are often common features that many applications need. That's why they've been open sourced. However, they're available through a special tool called NuGet, which is a repository that's maintained by a foundation supported by Microsoft, but ultimately its own entity. All right, and so there are a number of different ways to work with NuGet in Visual Studio. I'm going to choose the visual way to do it, and I find that to be the easiest for those who are just getting started and for me because I'm a more visual kind of person. There's also a textual almost command line style interface that would allow you to do similar sorts of things and even script these things. So let's go to the Tools menu and select NuGet Package Manager and then Manage NuGet Packages for Solution. This will open up a tab. Undoubtedly, no matter what you see on my screen, it'll look different on your screen because this is going under active development for the last few years, and it has changed frequently. Now, if there were a package that we wanted to add to our solution, we could simply search for it. Typically, we can learn about these sorts of things through blog posts and what have you. Say, for example, I wanted to access a database from my console window application and I wanted to use the Entity Framework API from Microsoft. It's available through, as a NuGet package, through this Manage NuGet Packages for Solution dialog. So I can select it. I can select it as one of the options. You can see it's one of the most frequently downloaded. Furthermore, I would then choose which project in my solution that I wanted to add it to, and I can choose the Install button. There's some other options as well. I'll leave you to investigate those on your own. I'm going to go ahead and click OK. I agree to the terms for using the Entity Framework. And in this particular case, it installed just a number of references to assemblies and copied them down locally to my computer. Now, depending on the type of package, it could not only contain .NET assemblies, but also sample source code files. It could actually run macros inside of Visual Studio. It could include things like style sheets and HTML and even graphical assets that it will include your project. So this is the second way that we can go about adding assemblies and more to our projects. But the third way that I want to talk about is whenever we want to add a reference to a class library that we've created. Now, we haven't created a class library up to this point, so this is a perfect opportunity to do that and then add a reference to it in our project. So what I'll do is start off by creating a new project. Let me go ahead and let you see my entire screen here. And in the new project dialog, I want to make sure to choose C#, and then I want to choose class library. Notice that I chose the one that doesn't have the little NuGet logo next to it. It's just a little, looks like several books and the C# logo. Now this will undoubtedly look different to you, but just make sure that it's a regular old class library. And here we're going to call this my code library and click OK. And I'm going to go ahead and say I don't really care to save my other solution there. All right, and so inside of this you can see that I don't have a program.cs. All I have is a class1.cs. There's no static void main. And so what I'll call this is the scrape class, and we'll have one public method. So public string scrape web page, and we'll create a version of this where you provide it just the URL, and then we'll create a second version of this where you provide the URL and a file path. All right, and so in this first case, I'm just going to copy down some of the code that we worked with previously to create this functionality where we were actually using this web client to go out, download a page, and then save it to a text file. I'm just going to generalize this. Remember what I did previously when I hit Control period on the keyboard in order to add a reference to system.net or add a using statement for system.net. And the next thing I'm going to do here is actually replace this hard-coded string with whatever gets passed in by the end user. All right, finally, I'm also going to have to add or resolve this reference to the file class. It's in the system.io namespace, so I'm going to add a using statement for that. However, in this specific case, I'm not going to write this to a file in this overloaded version of it. In fact, what I'll just do is return whatever's been input actually downloaded from client.downloadString. All right. Now the second version will do something almost identical. Here, let me replace this with URL, and we'll get rid of console.writeLine, and we'll go ahead and write this to the file path that was passed in, and then we'll return the reply. Now, truth be told, this might be a good situation where I could actually take these lines of code and create a private helper method out of them, and maybe that's a good idea. Let's do that right now. Private string get web page. All right, and we'll pass in the URL. And so here, and now both of these can just call, get web page, like so. And here we'll go string return or reply equals get web page. All right, see what I did there? How I was able to use a private helper method to encapsulate the functionality of actually getting the web page itself, and then in this case I was able to extend the scrape web page method to include writing that to an actual file path. All right. So now that I've created this, and let me go ahead and rename this file as well by right-clicking on it and selecting rename, and I'm going to choose to name this file scrape as well. I could name it anything I want. It won't matter because the name of the class itself is scrape. But at this point now, I'm going to go ahead and build the solution. It looks like it built. In fact, let me go ahead and build a release version of this. All right, great. So now let's open up a second version of Visual Studio, and I'm going to call this my client. So this will be a console application called my client, and we'll click OK. And what I want to do is to, first of all, add a reference to that DLL that we created just a moment ago. So I'm going to go and right-click on References and select Add a Reference. All right, so here I have some choices. Ideally, I would be able to look and find it in the same solution. We'll come back to that and do it in just a little bit here. But I may have to go and actually browse through the file system to find this, and unfortunately this is popping off the screen. However, hopefully we can work our way through this. And I'm going to navigate to the bin directory, into the release directory, and find my code library, and then I'm going to select the add button and then click OK. All right. And so now that I've done that, what I should be able to do is get to the scrape class, right? But it doesn't see the scrape class, so I'm going to hit Control period on my keyboard, and notice that it will find the correct using statement. The using my code library namespace scrape, my scrape equals new scrape. Okay, and now I should be able to go my scrape dot, and there we go, scrape web page, and I should be able to give it a URL. So let's go all right, and that should return a string. So string return, or actually just value equals, all right, let's move this over a little bit. And then I should be able to print that to screen. So console.write, like so. And now we should be able to run the application. And it takes a moment, but it pops up. All right, so what we're able to do there, well, we created a reusable library now, so whenever we want to scrape a web page, we can utilize this in any of our other projects. Now, did you find how inconvenient it was to actually go and search around whenever we wanted to add a reference to it? I had to go and browse through through all my projects and everything. But I do want you to notice one thing about what happened after we did that. Let's go to my projects and let's find that client and let's navigate into the bin directory, and notice that it copied my code library.dll into the bin directory for the client application. So that's one of the things that it will do with any of the third-party assemblies that it will utilize. All right, but wouldn't it be easier if we were to start this over from scratch and we were to create a single solution that had both the client and the code library in the same solution? So let's do that now. I'm going to actually open up a third copy of Visual Studio. And here, let's create a new solution. So what I'm going to do is actually scroll all the way to the bottom and choose Other Project Types and choose Visual Studio Solutions and find Blank Solution. Now, this might be in a different place, so you may have to kind of hunt around for it, but you ultimately want to choose Blank Solution. It should be available to you. And we're going to call this Lesson 18. So the solution's name will be Lesson 18, but what we're going to do is add projects to this solution. So the first project that I'm going to add, and there's a number of ways to do this, like add, but it goes off to the right-hand side of the screen. I could add new project. File, add new project, and then we're going to choose the class library. So we'll call this the scrape library. All right, and then I'm going to choose to create another project and add it to our solution called of type console application, and this will be the scrape client. Okay. All right. So in our scrape library, what I'm going to do, just for simplicity's sake, is actually go to the work that we've done here a moment ago, and I'm going to copy all of this, like so. And let's come back here, and I want to paste all this in, like so. And yes, I'm going to have to resolve these class names by adding using statements here and here as well. All right, that should work. Looks like I actually lost my class name, so let's go public class scrape. And then let's make sure to put everything inside of it. All right, there we go. Now we get it working. And I'll rename this as well to just scrape. I could have left it, called it class 1, but that'll work just fine. Okay, so I'm going to go ahead and build that. Right-clicked on the project name and selected build. All right. And now what I want to do in the client to utilize that class library is I need to add a reference to it. So here again, I'm going to right-click and select Add Reference, and this time I'm going to go to Projects, and notice if Solution is selected, the scrape library will be an option. I'll choose that and click OK. And now we can utilize Scrape Library in our application. So let's go ahead and just type in the word scrape scrape dot, and it's not going to find it. So I'm going to hit Control period, and I need to add a using statement. Since I renamed it, now it's called Scrape Library. So I'm going to add the Scrape Library namespace to using statement to the code file. So scrape my scrape. In fact, I don't have to do all that, right? I can just copy and paste it from the previous client, like so. And we can rerun the application. Whoops. And it says a project with an output type of class library cannot be started directly. All right. Why do you suppose that happened? Well, because there are actually 2 projects now in my solution, and you can't execute a library, correct? So what we need to do is right-click on the client project and select Set as Startup Project. And now, let's go ahead and close that. When we attempt to run the application, it'll work. Furthermore, if we were to make any changes to how the library actually works, let's say, what could we do here that's interesting? Let's do this. We'll make a change in one spot. And then I'll go content plus equals, that's all folks for the very end, all right, of that string that's returned. And I'll return content this time. All right, let's make sure we add everything there. So we've made pretty big change to the application, and now when I run the application, it will recompile the DLL. It will add it to our project, and at the very end, it adds "that's all, folks." Okay, it's just the only thing I can think of off the top of my head. All right, so hopefully now you can see that there are several different ways to add assemblies. If it's part of the .NET Framework class library, then obviously there's a way to do that. If it's a free or open source package that's available from NuGet, we can use the NuGet package manager, or we can create our own third-party class library and then add a reference to it by browsing. Or if we were to create the client and the library inside of the same solution, then we can reference it in the add reference dialog, but just under the project solution option. And we get the added benefit of being able to make updates, not having to go through 2 copies of Visual Studio to update it. It'll all be just, it'll update the next time we hit run. It'll recompile it and everything. Okay, so at any rate, that's pretty much it for this lesson. We'll continue on the next lesson. We'll see you there. Thanks.
That's all for this episode. I hope this tutorial was helpful. Is your mind ringing with questions, queries, or doubts? Do you wish to learn more? Then visit our website www.millionlights.org and post your questions on our forums. We will be extremely happy to clear all your doubts. If you missed anything and want to rewatch it, you can download it from our website or can watch it online as well. You can also participate in our webinars, discussions with a subject expert, as well as get Microsoft certification on various courses through our website. You can also find us on Facebook by the name of Millionlights, as well as on Twitter. For more such interesting tutorials on coding, keep watching Microsoft Hour of Code, brought to you by Millionlights. Thank you.